Our planet's atmosphere has been warming recently, and the cause is something called greenhouse gases. But what exactly are greenhouse gases, and how do we know they cause our planet to warm up? The objects on this table are at room temperature, each more or less as warm as the objects next to it. But some things are warmer than others, like this cup of tea. Because the cup of tea is warmer, energy is flowing from the tea to the room around it, in the form of infrared radiation. By using an infrared camera, we can watch the cup of tea cool as it transfers energy to the room. Over time, it will reach the same temperature as the other objects around it. In science, this transfer of energy is what we call heat. Now, let's step back and imagine our planet. Our sun is continually transferring some of its energy to our planet. Much of that energy travels right through Earth's atmosphere and reaches the surface, where it is absorbed and re-emitted into the atmosphere in longer infrared wavelengths. If all of that energy passed through the atmosphere directly into space, our planet would be quite cold, on average around -18 degrees Celsius. But infrared energy can interact with certain gases in the atmosphere, which are known as greenhouse gases. These gases interrupt the flow of energy escaping from Earth, holding some of that energy in the atmosphere. It is a little like throwing this towel over this heating pad. The towel interrupts the flow of heat, trapping the energy near the surface of the pad. A simple experiment will demonstrate which atmospheric gases behave in this way. Here are 4 cylinders filled with 4 atmospheric gases: nitrogen, oxygen, carbon dioxide, and methane. Notice the gases are transparent to visible light, just like the atmosphere. But in this experiment, we'll test which ones are transparent to infrared light. This heating pad emits infrared wavelengths and will simulate our planet's surface. We've sealed the ends of each cylinder with thin plastic wrap, because glass itself blocks infrared radiation, but the thin plastic doesn't. We'll start with a cylinder filled with nitrogen gas and place it between the infrared camera and the heating pad. Looking down through the cylinder, we notice that the infrared energy passes right through nitrogen without being absorbed. If we try the cylinder filled with oxygen gas, we get a similar result. But carbon dioxide is a different story. Notice how the image in the infrared camera becomes much cooler. This reveals that the carbon dioxide is absorbing some of the infrared energy given off by the heating pad before it can reach the camera. And here is methane. Methane also absorbs the infrared radiation. So, greenhouse gases, like carbon dioxide and methane, are gases that absorb energy, trapping more energy in the atmosphere. But to see if greenhouse gases actually behave this way in the atmosphere, we have to move from our tabletop experiment to the real world. The first piece of evidence comes from a satellite measuring the wavelengths of infrared energy escaping from Earth's atmosphere. Since the precise wavelengths absorbed by each greenhouse gas are known, the satellite should detect gaps at those precise wavelengths. This curved line shows what would be detected if no gases were absorbing energy. And this squiggly line shows the real measurements from the satellite. The difference between the curved line and the squiggly line reveals the energy being absorbed by greenhouse gases. These wavelengths here are missing because of carbon dioxide, and this dip is caused by methane. And these gaps show wavelengths absorbed by water vapor and ozone, 2 other important greenhouse gases. This is the energy that doesn't escape through the atmosphere and remains behind to warm the planet. Next, we have to see if a change in the amount of greenhouse gas in the atmosphere causes a rise in global temperature by looking at things over time. Here is a chart that shows a 40% rise of atmospheric carbon dioxide over the last 60 years. And here is a chart that shows global temperature over the same period. The average surface temperature of our planet has been rising at the same time as we've been putting more and more greenhouse gases, like carbon dioxide, into the atmosphere. So, given our little experiment and the evidence from real-world measurements, it is very difficult to ignore the fact that greenhouse gases are causing our planet's climates to change. And once we realize this, we have to ask ourselves, what are we doing about it?